Our series lecture 4. They want us to find the series for ln into ln of 1 plus x. Now we shall first of all a solution. Now Maclaurin series f of x is given by f of naught plus x dot f of naught prime plus x squared f of double prime over 2 factorial plus x cubed f of triple prime all over 3 factorial plus x raised to 4 all over 4 factorial plus x raised to 5 all over 5 factorial, like that. Now so once we have this, so from the given equation we can see that our f of x is equals to ln of 1 plus x so when we put x equals to 0 in this equation, so we shall have f of naught equals to ln of 1 plus 0, which equals to ln of 1, which equals to 0. Therefore we are saying f of naught equals to 0. So we have that. So we differentiate f of x. When you differentiate f of x, we get f of x prime, which equals to, when you differentiate ln of 1 plus x, you get 1 all over 1 plus x. So this is the same as 1 plus x raised to negative 1. Then we put x equals to 0. So our f of naught prime will be equal to, now we have 1 plus 0 raised to negative 1, which equals to 1 raised to negative 1, which equals to 1. Therefore our f of naught prime equals to 1. So we have that. Then we differentiate f of prime. So when you differentiate f of prime, we have f of double prime x, which equals to, when you differentiate this equation, we multiply by the power which is negative 1. So it negative 1 into 1 plus x, then the power minus 1. So it will be minus 2. So this is the same as negative 1 all over 1 plus x raised to 2. Then we put x equals to 0. Therefore our f of double prime naught will be equal to, so we have negative 1 all over 1 plus 0, then squared. So this equals negative 1 all over 1 squared, which equals negative 1. Therefore our f of double prime naught equals to negative 1. We have that. So we differentiate f of double prime, so we shall have f of triple prime x equals to, so when you differentiate this equation, you take negative 2 times 1, we have 2 into 1 plus x, then the power is negative 2 minus 1, we have minus 3. So this is the same as 2 over 1 plus x raised to 3. Then we put x equals to 0. So we shall have f of triple prime naught to be equal to 2 all over 1 plus 0 raised to 3. This is the same as 2 all over 1 raised to 3, which is the same as 2. Therefore, f of triple prime naught will be equal to 2. So we have this. So we differentiate this equation again, we get f of raised to 4 equals to, so you take negative 3 times 2, you have negative 6 into 1 plus x, raised to now negative 3 minus 1, you have minus 4. So this is the same as negative 6 all over 1 plus x raised to 4. Then we put x equals to 0. So we shall have our f of not raised to 4 will be equal to, now we have negative 6 all over 1 plus 0 raised to 4, which equals negative 6 all over 1 raised to 4, which equals negative 6. Therefore, equals negative 6. So we have this. So we remain with this. So we differentiate this equation again. We get f of x raised to 5 equals to negative 4 times negative 6. We have 24 into 1 plus x. Now raised to negative 5. So this is the same as 24 over 1 plus x raised to 5. Then we put x equals to 0. So our f of not raised to 5 will be equal to 24 over 1 plus 0 raised to 5, which equals 24 over 1 raised to 5, which is equals 24. Therefore, our f of not raised to 5 is equal to 24. Okay, now that we have all the constants, so we shall say, therefore, ln of 1 plus x will be equal to our f naught. Our f naught is 0, to be 0, plus x dot. Our f of naught prime, our f of naught prime is 1, so x times 1, then plus x squared dot. Our f of double prime, our f of double prime is negative 1. We have negative 1 all over 2 factorial, like that. Then plus x cubed. Our f of triple prime is 2. So we have 2 over 3 factorial. Then plus x raised to 4, which is this one. Our f of not raised to 4 is negative 6. So we have negative 6 all over 4 factorial, because we are multiplying there. Then plus x raised to 5. Our f of not raised to 5 is 24. So times 24 all over 5 factorial. Continues like that. So this equals to, now here we have x. Here we have minus x squared all over 2. So here we have plus x squared all over 3. And then we are saying that because remember here we have 2 all over 3 factorial. So 3 factorial equals to 3 times 2 times 1. So 2 times 1, so this 2 times 1, which is 2, it will cancel with this 2, and then we remain with this 3. That's why here we are remaining with x squared all over 3. Then here we have minus now 6. Now 4 factorial. 4 factorial is the same as 4 times 2 times 3 times 1. Now 2 times 3, this is 6 times 1, so this is 6. Therefore, this 6 will cancel with this 6, and then this 4 remain. We remain with this we have x squared, so we have 2, so we have minus, so we have 4 factorial. So here we remain with x raised to 4 all over 4. We shall remain here with that 4. This 6 will cancel with that 6. We remain with this 4. That's fine. Then plus here we have 25 factorial. 5 factorial is the same as 5 times 4 times 2 times 3 times 2 times 1. This 24 will cancel with this 24. 4 times 3 times is 24, so it cancels with that, so we remain with 5. So we remain with x raised to 5 all over 5, and it continues like that. So this is now the series for ln of 1 plus x minus x squared all over 2 plus x squared x squared, this is x, so we have x squared, this is x cubed, this is x cubed all over 3 minus. So you can see that these are the natural numbers. They are not the factorials, because we have been cancelling these constants. So thank you for watching and listening.